Hello, guys. So it's Monday. This is the first episode of Let's Study. I don't really want to study, but we still have to do it. So let's go. And today I'm planning to study pathophysiology. I need to run for my university in some time. So let's start studying. So today's topic is photosensitivity. So what is it about? Toxic agents build up in the blood when they reach the skin. Okay, this is photosensitivity. Okay. Okay, so toxic agents that can form on the skin whenever the sunlight hits on it, it triggers the immune reaction. Okay, got it. So this is it can occur in ruminants, cattle, sheep, goats, dogs, so on and so forth. What are the agents that cause the photosensitivity? Chemicals, microbial in origin, plant derived, and other stuff. Microbial, plant derived, and other stuff. So photosensitivity can be split into four types. Actually into two types, primary, secondary, and then a third type, which is type 4. Primary is split into 2, secondary is 3. Okay. Okay, looks like I haven't shared my screen. Boom, here you go. So the topic for today is photosensitivity, and this is what I just was reading. These are toxic substances that reach the skin and react with sunlight. Whenever they hit the light, they trigger the immune reaction. This is called photosensitivity. It can occur in ruminants, cattle, horses, dogs, cats, and so on and so forth. So photosensitizing agents are microbial, plant, and other stuff. So it can be split into three types: primary, secondary, and type 4. And then the primary is 1 and 2 and 3. Photosensitivity occurs when the skin has increased susceptibility to non-burning doses of UV light. Okay, primary photosensitivity. Okay, plants that enter, things that agents that enter through the GI tract or through the skin contact. Okay, and hypericin, phagopyrin, furochimerins. Agents. Okay, so these are the plants that are causing types of hypersensitivity. In this case, type 1, primary, St. John's Wots. Okay, buckwheat. Let me check the stream if everything is fine. Yeah, everything looks okay. Okay, pharmaceuticals, drugs as well cause hypersensitivity like phenothiazine, sulfonamide, antibiotics, tetracyclines, and so on and so forth. Coal tar derivatives. Okay, plant origins, pharmaceuticals, and coal tar. Phenothiazine, sulfonamide, antibiotics. porphyrins. Type 2 primary photosensitivity. Okay, type 2 photosensitivity, primary photosensitivity deals with enzymes, defects in enzymes that cause in the heme synthesis. Okay. Sensitizes porphyrins, endogenous pigments, congenital erythropoietic porphyria. Erythropoietic, that means red blood cell forming creation of it, birth of red blood cells and stuff. So congenital by birth, I think. And hereditary defect in cattle, sheep, and stuff. Decrease in activity of uroporphyrin co-synthase enzyme. And to okay. So it deals with the red blood cell production point, the origin point where decrease in the activity of uroporphyrinogen 3 co-synthase. Okay. Enzyme that converts uroporphyrinogen 1 to 3. So because that enzyme is not there, uroporphyrinogen 1 accumulates in erythrocytes, finally converted to porphyrin 1. Instead of uroporphyrinogen 3. Okay. So when they release that in circulation, when exposed to sunlight, porphyrins 1 can lead to the free radicals. Okay, that can interact with DNA protein lipid causing tissue damage. Okay, I heard it in cattle. Okay, deficiency of ferrochelatase. Okay, protoporphyrin 9 to form heme. Okay, whenever iron joins protoporphyrin 9 to form heme, deficiency lead to high concentrations of protoporphyrin in erythrocytes and tissues and decreased of hemoglobin production. And yeah, so the secondary photosensitivity is type 3 here, the most frequent type of photosensitivity in animals. Liver damages with bile duct lesions And photosensitizer here is phyloerythrin. Here it's porphyrins. Okay. Porphyrins, here phyloerythrins. Okay. They are from chlorophyll broken down from microorganisms. Okay. Normally it is absorbed in the blood and enter the liver where it is excreted into the bile. It's in a phototoxic reaction. And poisoning plants. Okay. When ingested cause liver damage. Okay. So these are the plant species. When ingested they cause the liver damage. In this case we saw the bile duct damage and other stuff. And reaches the skin can absorb and release light energy, a phototoxic reaction. Phyloerythrin is cause liver damage. Okay. Phytoporphyrin or phyloerythrin. So it's mostly associated with liver damage and stuff. Type 3, most common one. When they reach the skin. Okay. Type 4. Pathogenesis is unknown. Okay. What causes the type 4 hypersensitivity is unknown. Develop clinical regardless of the cause and clinical signs are similar. Okay. Skin pigmentation and intensity of sunlight and time of exposure. Okay. They feel uncomfortable, they feel reluctance, visceral. Uncomfortable. Squirm, rub or scratch. Edema, edema, serum exudation, necrosis and scabs. Also secondary infections. Okay, these are all the things we can observe. Rhythema is redness, icterus is yellow discoloration of skin and mucous membrane. Okay. So the stress and extensive skin necrotic lesion may highly debilitate animals and may lead to death. Okay. So here we can see some of the examples. Type 4. Wow. Type 3. The liver one. Hepatogenous. Okay. This is the most common, like they say, type 3, type 3. And okay. Wow, this is how it looks like. Okay. So biological factors and causes we kind of know: virus, bacteria, protozoa, worms, and insects. We mostly know all of those, at least from the last year, so I don't need to go through them. And nutritional disorders. Okay, so this is what I need to study for now. Then genetic, and then what else? Electrolyte water imbalances. Okay. Electrolyte acid base balance. Okay. Nausea, vomiting, hormonal disorders. Okay. Thyroid, more hormonal disorders. Pruritus and stress. Metabolism, and thirst. See. Let me check the stream. Yeah. Cannabis with the pain. Okay, a lot of stuff. Okay, let's go through nutritional disorder quick. We have 15 minutes or so. Nutrition derived from digestive tract to the ingestion of food and liquid feedings. Carbohydrates, fats are broken down and transformed. This process called metabolism. No other than the body requires more than 40 nutrients on a daily basis. Daily intake of the nutrients is in food should be assessed, but very often recommended allowances are also established for every nutrient are given, safe or adequate. When excess nutrients are available, they frequently are stored for future use. When the tissue's concentration of nutrients is critically changed, cellular metabolism becomes distributed. Poor nutritional status can cause illness and prevent recuperation from illness. Okay. Controlled by body systems that generate integrated effect and specific neutral and hormonal signals. Afferent systems generate humoral signals and adipose tissue and okay, let's go through. Overnutrition, undernutrition. Okay, these are the reasons. These are some of the reasons why obesity is observed. We can observe the following defects per se, like hyperinsulinemia, dyslipidemia, increased plasma leptin, insulin resistance of liver cells, okay, increased arterial pressure and hypertension, activation of renal angiotensin system. Obesity is known to run in families, suggesting hereditary. Okay, the excess body fat often significantly impairs health. They stress the bones and joints. Stroke, cancer, pulmonary dysfunction, pulmonary deep vein thrombosis, poor wound healing, and mortality. It's hard on lungs, and puffing, heart conditions, heart blockages, yeah. And also makes the heart work more harder. They're prone to skin infection, dermatitis, and stuff. Added strain to joints and ligaments can worsen pain, make it harder. Reduced activity, yeah, I can imagine. So undernutrition is when the tissue concentration of nutrition falls to low or critically low. It can be from lack of food availability, health problems that impair food intake, decrease its absorption and use, and lead to loss of adipose tissue and muscle mass. Undernutrition is when the tissue concentration of nutrients falls to low or critical level. Okay, it can result from lack of food availability, health problems that impair food intake. Food availability, health problems, impair the food intake. Like any dental issue, jaw related issues. Loss of adipose tissue and muscle mass also could be a reason. And then acute level and chronic. Okay, acute and chronic. Acute could be like some kind of a disease, I guess. Okay. Chronic could be something slow and painful, and a spine with acute thiamine deficiency may die suddenly. Ah, yeah. Acute is sudden. Okay. See few lesions in cardiac muscles, whereas those with chronic deficiency have severe lesions. Okay. Severe lesions in heart. Acute deficiency, chronic deficiency. Simple deficiency and multiple deficiency is caused by eating a poor quality diet with deficiency of one particular dietary factor. Calcium and phosphorus, calcium and iron and phosphorus. Excess of one can lead to the deficiency of another, multiple deficiencies. Poor quality of diet, that is apt to be lacking in several. The syndromes that develop are different from the combined effects of individual deficiencies. Factors contributing to nutritional deficiency are interference with intake, interference with absorption, storage, increased requirements, nutritional inhibitors. Okay. Malnutrition and starvation are conditions in which the animal does not receive or is unable to use adequate amount of nutrients. Factors contributing to nutritional deficiencies are intake, absorption, storage. Okay, intake, absorption, and storage. Okay, and also excretion and increased requirement, let's say during pregnancy and stuff. Okay, lactation, yeah. Nutritional inhibitors, thiaminases. So malnutrition, starvation. Yep, let's quickly do that. So malnutrition could be primary, secondary. It may be primary due to inadequate food intake or secondary due to disease, the tissue wasting. Okay. Malnutrition is the amount of food that is consumed and then that is actually absorbed is completely or drastically reduced. Primary, secondary is inadequate food intake is primary. Being a rare urban suffered malnutrition in early years and now sports a oddly shaped shell. Okay. Poor thing. No. In Michigan. Okay. Secondary is a tissue wasting and okay. Metabolic changes lead to loss of adipose tissue, muscle, and net protein intake. Net protein breakdown is accelerated and net protein rebuilding is disrupted. Okay, a lot of muscle mass and fat are all burned down to produce energy, and which makes the animal lose weight and become skinny and weak. And also protein rebuilding is also disrupted. That's also a thing. The loss from liver, GI tract, kidney, and heart organs are markedly reduced in size. As protein is lost from liver, hepatic synthesis of serum protein decreases. As protein is lost from liver, serum plasma proteins. Okay. Decrease in immune cells. Yeah, the loss of protein leads to decrease in myocardial contractility, cardiac output. There is a decrease in the immune cells. Mucosal atrophy with the loss of villi and small. Okay, this also leads to respiratory muscles gone, decrease in immune cells. Yeah, this one we just a lot of protein muscles. Myocardial contractility, cardiac output, pain medications, decrease the appetite. Yeah. Starvation is a state of extreme malnutrition and hunger, lack of nutrients. Short-term starvation 1 to 14 days, long-term is anywhere between 14 to 60 days. Depending on the pre-starvation state, metabolic events of starvation permit life to continue for months without caloric intake. Okay. So glucose in the tissue disappears from the Glucose used by the tissue that's needed by the cells and muscles and all the other organs disappears from the plasma, and also means that leading to decrease in insulin and increase in glucagon levels. A consequences of high glucagon low insulin ratio is hepatic glycogen depletion. Yeah, basically, right? Because low glucose there, glucagon is derived from the liver, or the glycogen stored in the liver is taken out, and it leads to hepatic glycogen depletion. In liver, glycogen is converted to glucose, glycogenolysis. There is. Okay, looks like I need to go to the university now. Let's finish it fast. The simultaneous increase in glycogen phosphorylase and decrease in glycogen synthase. So glycogen phosphorylase is the one that is responsible like a glycogen degradation and decrease in glycogen synthase for glycogen synthesis. Okay, these are some useful information that I need to read later. Now I have to rush to the university. So thank you guys. This is the first episode of I Don't Wanna Study. So yeah, I know it was not very well organized, and this is the first one. And I'm like a young YouTuber, so bear with me. It will take a long time for me to make a proper system and a template and how we can do it more efficiently. So thank you guys. See you. And just before that, let me